Hi, this is Nathan Tintle. In this video, we're going to talk about how to make predictions about centers or means, as well as about variability and standard deviations based on the context of a variable. We'll start talking about the Old Faithful data set from the Intro to Statistical Investigations textbook. Here we see 222 observations of the time until next eruption of the Old Faithful geyser. We see two clusters of observations with a pretty wide range of values. Could you have predicted this? That probably would be pretty challenging unless you're someone who studies geysers on a regular basis. But a lot of times in statistics, when we're doing research and we're thinking about data, we do have some sense of what's going to happen next. For example, imagine you and a friend are doing a study looking at the ages of restaurant goers at nearby restaurants. Your friend goes to McDonald's near the interstate and for a couple of hours in the morning records the ages of all the people who come to the restaurant. You, on the other hand, you go to the snack bar on your college campus and, like your friend, sit for a couple of hours and record your estimated ages of people who visit the snack bar. Now, if you were to compare the standard deviation, or variability, of the ages of the individuals who visit these two restaurants, what do you think you would see? Well, the snack bar on your college campus probably is primarily serving college students. We expect then not to see much variability in the age of the people who visit that snack bar, so the standard deviation is probably fairly small. On the other hand, the people who visit a McDonald's likely represent all kinds of ages, from families with small children up to older individuals. And so probably what you're going to see is a much larger standard deviation due to the much larger variability in people's ages of those who visit the McDonald's. It's not always easy to predict what the standard deviation will be or how the means might be different between a couple of groups, but you should always stop and think about the context of the data that's been gathered before doing any computations. Either way, it's beneficial. For example, if you've thought about it and you have some sense of, I think this is going to happen. I think McDonald's is going to have a bigger standard deviation than is the snack bar at your college campus. And that's what you find in the data. That's nice. The data confirms your intuition, shows you that you probably collected the data well, and things worked out. On the other hand, if your intuition is wrong and you've thought about it and the data doesn't represent that, that can be beneficial, either helping you to understand better why your initial reaction or prediction was wrong, or that maybe there's a problem in the way you analyze the data, or the way you gathered the data, measured the data, the way you use the computer or calculator to perform computations on it.